Welcome to Part 2 of Video 1. In this part, we cover two essential topics, the highest common factor and the lowest common multiple. Both appear regularly in EASA Part-66 exams. Before we tackle HCF and LCM, we need to be clear on what a factor is. A factor of a number divides into it exactly, with no remainder. For example, let us find all the factors of 12. 1 times 12 gives us factors 1 and 12. 2 times 6 gives us factors 2 and 6. 3 times 4 gives us factors 3 and 4. So the complete factor list for 12 is 1, 2, 3, 4, 6, and 12. The highest common factor, or HCF, is the largest number that divides exactly into all of the numbers you are given. Let us find the HCF of 24, 84, and 120. The method is to list all factors of each number. Then identify the highest one they all share. Factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. Factors of 84, 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. And factors of 120, 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. Now we look for factors that appear in all three lists. 1, 2, 3, 4, 6, and 12 all divide into 24, 84, and 120. The highest of those is 12. So the HCF of 24, 84, and 120 is 12. The lowest common multiple, or LCM, is the smallest number that is a multiple of all the numbers you are given. Let us find the LCM of 6, 7, and 8. List the multiples of each until we find a common one. Multiples of 6, 6, 12, 18, 24, and so on. Multiples of 7, 7, 14, 21, 28, and so on. Multiples of 8, 8, 16, 24, 32, and so on. The first number that appears in all three lists is 168. So the LCM of 6, 7, and 8 is 168. Listing multiples is reliable, but slow. In exam conditions, you need a faster method. Prime factorization is the standard approach used in the EASA syllabus. The 3 steps are as follows. First, write each number as a product of prime factors. For the HCF, take each prime factor the lowest number of times it appears across all the lists. For the LCM, take each prime factor the highest number of times it appears in any of the lists. Using prime factorization on our example, 6 equals 2 times 3. 7 is already prime, so it equals 7. 8 equals 2 to the power of 3. For the LCM, we take the highest power of each prime. 2 to the power of 3 from the 8, times 3 from the 6, times 7. That gives us 8 times 3 times 7, which equals 168. Same answer, much faster. Pause the video now and try this yourself. Find the LCM of 5, 12, and 20. Here is the worked answer. 5 is prime. 12 equals 2 squared times 3. 20 equals 2 squared times 5. For the LCM, take the highest power of each prime. 2 squared times 3 times 5. That is 4 times 3 times 5, which equals 60. The LCM of 5, 12, and 20 is 60. Question 1. What is the LCM of 6, 7, and 8? Pause and choose your answer. The answer is B, 168. 6 equals 2 times 3. 7 is prime. 8 equals 2 cubed. LCM takes the highest power of each prime. 2 cubed times 3 times 7 equals 168. Question 2. What is the HCF of 24, 84, and 120? Pause and choose your answer. The answer is C, 12. The prime factors common to all three numbers are 2 squared and 3. Multiplied together, that gives 12. Question 3. What is the LCM of 5, 12, and 20? Pause and choose your answer. The answer is A, 60. Take the highest power of each prime. 2 squared times 3 times 5 equals 60. Here is your reference card for this topic. For the HCF, take the lowest power of each prime factor that is common to all numbers. For the LCM, take the highest power of each prime factor from any of the numbers. And remember, for exactly 2 numbers, the HCF multiplied by the LCM equals the product of those 2 numbers. That wraps up Part 2. You can now find the HCF and LCM using both the listing method and prime factorization. In the next part, we move on to fractions.